Alright, these are the notes for Algebra 2, Section 4.2, pages 245 through 248 in your textbook. And we're looking at graphing quadratic functions in vertex form and in intercept form. Let's start with vertex form. Now, the vertex form of a quadratic function is y equals a times x minus h squared plus k. Now that might look familiar to you. As you should remember, when we did absolute value functions, we saw that absolute value functions were y equals a times the absolute value of x minus h plus k. Very similar to the vertex form of the quadratic function. In fact, the only difference is that instead of the absolute value of x minus h, it's x minus h squared. So what that means is that a lot of the things that are true of absolute value functions are true of quadratic functions. Now let's look at this a little bit more in depth. The graph of y equals a times x minus h squared plus k is the parabola ax squared translated horizontally h units and vertically k units, just like the absolute value functions. H told us how far to the left and right it went. K tells us how far up and down it goes. The vertex of the parabola is just like the vertex of the absolute value function. It's hk. So if we know h, we know k, we know the vertex. That's what makes the vertex form so useful, because we can immediately see where the vertex of the parabola is. And of course, if we can find the vertex of the parabola, then we can find the axis of symmetry, because the axis of symmetry goes through the vertex. And it's the line x equals h. Last piece of information, just like with standard form, the graph opens upwards if a is greater than 0. That means if a is positive. The graph opens downwards if a is less than 0, if a is negative. So using this information, we'll be able to graph parabolas in vertex form. So let's give that a try. Looking at example 1, we want to graph y equals 1/2 times x plus 1 squared minus 2. And we want to follow the steps that are listed because they give us a blueprint of how to graph this. Now, first thing we want to do, step 1, is identify the constants. The constants a, h, and k. The number in front of the parentheses is a. H is inside the parentheses, and k is in the back. So a, in this case, is 1/2. H, now we remember from absolute values that the h value, we have to change the sign. So x plus 1, the plus 1 becomes minus 1. Just like absolute values, the h changes signs. K does not change signs. It stays -2. So I've got my constants. A equals 1/2, h equals -1, and k equals -2. Now because a, 1/2, is positive, bigger than 0, the parabola opens up. So when I'm graphing it, I need to make sure that my parabola is opening upwards. On to the next step. My vertex, I want to plot. And I know that it's the point -1, -2, because h is -1 and k is -2. And the vertex is the point hk. And we want to draw the axis of symmetry at x equals -1. So let's do that. Start with the vertex. My vertex is at -1, -2, so that's over -1 and down 2. And there's my vertex. Now I want to graph my axis of symmetry. I'm going to thin this out a little bit. My axis of symmetry goes through the vertex, and the vertex is at x equals -1, so my axis of symmetry sits at x equals -1. So that's my second step. I found the constants. My first step is to find the constants a, h, and k. Second step, to plot the vertex and draw the axis of symmetry. Then I want to evaluate the function for two values of x. Now, when we did standard form, we were able to plug this into the calculator, and we can do the same thing here. If we plug in y equals 1/2 x plus 1 squared minus 2 into y equals, and we evaluate for and we look at x values, here are a couple that we might see. We might see that when x is 1, y is 0. When x is 3, y is 6. If we'd done it by hand, we should have gotten the same answers by plugging in numbers for x. And it doesn't matter what numbers, as long as it's not numbers that we've already used. So we want to plot these points. Now, when x is 1, y is 0. When x is 3, y is 6. So we want to plot the points 1, 0 and 3, 6. So I'm going to do that now. When x is 1, y is 0, so that's right here. When x is 3, y is 6. So over 3, up 1, 2, 3, 4, 5, 6. So I plot those points. Then I plot their reflections along the axis of symmetry, just like I did before with standard form. This point is 2 units away from the axis of symmetry. So I'm going to go 2 units away on the other side and plot the point. The point 3, 6 is 1, 2, 3, 4 units away from the axis of symmetry. So I'll plot the other point 1, 2, 3, 4 units away from the axis of symmetry on this side. Now I have 5 points. I can draw my parabola. That's terrible. Let's try that again. Not any better. That's okay. I have my point, so I know where it's supposed to be, even if my parabola is a little wavy. So, again, we have our 4 steps. We started by identifying the constants, a, h, and k. H changed the sign, the rest of them stayed the way they were. The vertex was the point hk, -1, -2, which I plotted. My axis of symmetry was at the x value of the vertex because it goes through the vertex. I then either plugged in random numbers for x and got values back for y, or I looked at my calculator and I got values for x and I plotted the appropriate points, and then I mirrored them along the axis of symmetry and drew my parabola. Now pause the video, go to checkpoint question number 1 and answer that question. When you're done, come back, unpause the video, and we'll look at intercept form. Intercept form for a quadratic function is y equals a times, in parentheses, x minus p, times, again in parentheses, x minus q. So we've got a, we've got p, and we've got q. Now these are a little different than what we've seen before. So let's look at how this works. We want to graph the equation, and there are some pieces of information that we can get out of the function. First of all, the x-intercepts, the points where y equals 0, the point where it crosses the x-axis, are p and q. And what you might notice is, again, just like the h value in vertex form and in absolute value form, p and q, you have to change their sign. So whatever is written in the equation for p and q, you have to change the sign so that you can graph it. Now the axis of symmetry is halfway between those two intercepts, p, 0, and q, 0. And we can find the axis of symmetry's equation by adding P and Q together and dividing by 2. Basically, we're finding the average of P and Q. The average of P and Q will be where our axis of symmetry is. Because the axis of symmetry should mirror it, that means P and Q should both be equal distance from the axis of symmetry. We can find it by finding the spot right in the middle. And just like before, if A is greater than 0, that means if A is positive, it opens up. If A is less than 0, if A is negative, it opens down. That's been the same for standard form, for vertex form, and now for intercept form. That A tells us if it opens up or down. Okay, let's look at how this works. I want to graph y equals negative 2 times x minus 1 times x minus 5. First step, I want to identify the x-intercepts. P is 1. P is 1 because it was x minus 1, but we have to change the sign to make positive 1. Q is 5 because just like P, we have to change the sign from negative 5 to positive 5. Now, because P is 1 and Q is 5, the x-intercept occur at the points 1, 0, and 5, 0. We want to plot those 2 points, 1, 0, and 5, 0. So, I will plot this point at 1, 0, and I will plot another point at 2, 3, 4, 5, 0. So there are my 2 x-intercepts. Now I've got those 2 points. I want to find the coordinates of the vertex. To find the coordinates of the vertex, the first thing I would do is find the axis of symmetry, which I can get by finding the average of these 2 points. So P plus Q divided by 2. P is 1, Q is 5, so 1 plus 5 divided by 2 is 6 divided by 2, 3. My axis of symmetry then is at x equals 3. And I'm going to draw that line. Here's the line, x equals 3. That's my axis of symmetry. And just like with standard form and just like with vertex form, we need to plug in the x value to get the y value. So that's what we're going to do. We plug in 3 for x to get the corresponding y value for the vertex. So it'll be negative 2 times 3 minus 1 times 3 minus 5. And if we work this out on our calculator, we have negative 2 times 2, negative 4. Negative 4 times negative 2 is positive 8. And if, you can work this out on your calculator and you'll get this answer. So when x was 3, y was 8. That means the vertex is at the point 3, 8. And I'm going to plot that point. 1, 2, 3. The vertex should be on the axis of symmetry. And it should be up 1, 2, 3, 4, 5, 6, 7, 8. Right here. Now I've got, in this case, I don't need to worry about plugging in any extra points. It's acceptable just to do these 2. And I will draw a parabola, however poorly, that connects these points. And there is my quadratic equation. Alright, now pause the video or stop the video and answer checkpoint question 2. You need to make sure that you bring your completed notes and the completed example problems to class.